Good day and welcome to our class. Today we want to talk about distance between 2 points in three-dimensional coordinate system. But before we talk about that, we need to first talk about the Cartesian coordinate, three-dimensional Cartesian coordinate itself. So the three-dimensional Cartesian coordinate is of the form this. We place this place to be y-axis. We place this place to be z-axis. And we now turn this place to be x-axis. Just like what we have in two-dimensional coordinate system, the negative part. So this is the negative part of the x-axis. This is the negative part of the y-axis. And this is the negative part of the s-axis. This is a plane. So we need to draw it so that the angle between this will be 90, will be right angle, which is 90. This 90. So you need to draw it parallel to this x-axis, and you draw this one parallel to this y-axis. So this is how three-dimensional coordinate system looks like. Now the next thing is, how can we locate a point in this three-dimensional coordinate system? Now let's take an example to explain further. Now finding the position of point this in 3D. Now let's consider this point. Let's we want to find this point. So first note that all of them are positive. So we only draw the positive axis. So this is x. This is y. This is z. Now let's count 2 for. This is how you draw it. This is 1 and this is 2. And let's count 3 for x. For y, 1, 2, 3. And for z, let's say it's 5. 1, 2, 3, 4, 5. Now, if you want to locate the point, the first thing is you need to locate the first 2 points, which is these 2 and 3. So that is where 2 meet. So this is 2. This is where s is 2. So you draw it so that it will be parallel to this y-axis, so that it will come and meet this and you draw this y-axis too, so that it will be parallel to s-axis. They will meet in this place. So this place now we'll call it point 2, 3, but it is a 3D, so the next one will be 0. Now where they will now meet, these 2 and 3 will go and meet 5 at z is equal to 5. So you draw this final one parallel to z-axis. So you need to count it to 1, let's say 2, 3, 4, let's say this is 5. So this place is our point 2, 3, 5. So we can decide to continue the point so that this place, as you can see, this place, as I can decide to continue the point so that it comes to 5, as you can see there. So as you can see, it will be parallel to that. This will be parallel to x-axis here, and this will be parallel to y-axis. As you can see, it looks like a cuboid. So this is a point we are looking for. Now let's take another example. See another example here. We want to locate point this. So this is our s, y, and z axis. But because this y is negative, we need to draw the negative part of x. So this is negative part of y. So we counted 2 for s, 1, 2. And we counted 1 for y because it is negative. We counted it backward there. Also for z, we counted 3, 1, 2, this is 3. Now 2 and 1 will meet. So this is where 2 and 1 will meet. So we need to draw it so that it will be parallel to this y-axis here. So at the end of the day, this is y here. They will come and join here. This one will be parallel to s-axis. This is parallel to y-axis. At the end of the day, they go and meet z at 3. positive 3. So this is 1, 2, and point 3. So this is the point we are looking for. So that's how to locate point in 3-dimensional Cartesian coordinate. Now suppose that the question is 2, minus 1, minus 3. As you have first done this, you need to draw the negative part of z. So this one, they will come and meet here. You need to count 3. 1, 2, 3. So that it will be parallel to z axis. So this is the point here, 2, minus 1, 3. So this is the point we are talking about here, and this one, this is the point here. Now we can now move to distance between 2 points. Now the distance between 2 points. We have considered a Cartesian coordinate 3D system here. We want to find distance between these 2 points P and Q. We assume that point P is S1, Y1, Z1. This is Q. But if you look at A here, you will see that A is assumed to be point S1, Y1, 0, and point B is S2, Y2, 0. Now, we need to draw something perpendicular, parallel to this. Let's say this place is point N. Let's say this is point N. So that P and N will be the same thing as A and B. So in order not to stress ourselves, in two-dimensional coordinate system, we can find AB square. Because we know by the formula under two-dimensional coordinate, we know that the formula of finding distance between 2 points is this. So let's keep that. This is our AB. Our aim is to find PQ squared and PQ later. Now we need this QN. The question is, what is our N? You see that N is on this. The N is on S2, Y2, because it's still close to this. But now it has moved to Z plane. This place is on point S1 here. So it has moved to the Z plane. So the third one will have been Z1 instead of Z2. It will have been Z1. So by Pythagoras theorem, we know that PQ squared will be equal to PN squared plus QN squared. But we know that PN squared is same thing as AB squared. We know. Also QN, normally QN, by the virtue of vector, if you want to find QN, we just subtract this minus this, this minus this. All we have left will be Z2 minus Z1. So QN is equal to Z2 minus Z1. So in that case, PQ squared will just be PN squared, which is this. I will write it, plus QN squared. This is our QN. Then we'll put square there. Z2 minus Z1 squared. So if you now make PQ the zero formula, that will be square root of the whole. So this is distance between 2 points. So this formula will find distance between 2 points, P here and Q here. Now let's take examples. So we want to find the distance between these 2 points here. So using the formula, this is our S1, Y1, Z1, S2, Y2, and Z2. So if we use the formula, we know that the formula is the. So we cannot substitute everything there. This is this minus this, 9 minus 3. This is S2 minus S1 squared plus Y2. This is Y2 minus Y1. Our Y1 is minus. So to nullify this minus, it will make it to be plus. All squared plus Z2 minus z1 all squared. So this will just give me 36. This will give me, this is minus 1 plus 4 is 3. 3 squared is 9, and this is 4. So 36 plus this is 45 plus this is 49, and square root of 49 will give me 7. So therefore the distance between these 2 points is 7. Let's take another example. We have a question here. Find distance between these 2 points. If the distance between these 2 points is 5, find the possible values of x. So we have known that the distance between these 2 points is 5. When we make use of this, that means our PQ is 5. So if you use the formula, we have 5 squared. PQ is given already, so I don't need to use the square root again. 5 squared into S2 minus S1. Is it this minus this? So that is 3 minus S all squared plus minus this minus 5. It will now become plus 8 all squared plus 4 minus 4. 4 minus 4 all squared. So this gives me 25. By the time we expand this, we should have s squared minus 6s plus 9. And this is minus 5 plus 8 is 3 squared is 9. So from this list, what we are going to have left to be s squared. If you simplify, this is 18. When we bring this one in, it will be 18 minus 25. That will be minus 7. So this leads to a quadratic equation. And solving a quadratic equation, we get s equal to minus 1 or s equal to 7. So these are the 2 possible values of s, for which the distance between this is 5. Let's take another example. Show that these points are vertices of isosceles triangle. Now, if you want to prove this type of thing, you need to pair these letters, this variable that is AB. We find AB squared, you find AC squared, and you find BC squared. You need to pair them together. So that's how to know. So that's the first thing to do. We pair them and you find it using the formula. Now, let's find AB now. That's the first thing. AB, from the formula, it is, we are dealing with these two, y2 minus y1. S2 minus S1, that is 6 minus 1 squared plus this minus this, 6 minus 5 squared plus 4 minus 0 squared. So that is this. We use the distance formula because AB is the distance between them. So by the time we finish it, we get square root of 42. Now let's find AC2. AC. We are not dealing with A and C. So we still use the formula. The beauty of it is that you can take anyone to be your S1 or S2. So this is this minus this. 0 minus 1 squared plus 9 minus 5 squared, this one, plus 5 minus 0 squared. So which at the end of the day will give me the same square root of 42. And finally, let's find BC. We are now pairing B and C. BC together. So if you find BC, we should have 0 minus 6 squared. The next one, 9 minus 6 plus 9 minus 6 squared plus 5 minus 4. And that will give me root 62. So what we have shown here is that ABC are vertices of isosceles triangle. We know that isosceles triangle, the properties, 2 sides are equal. So since we have shown that 2 of the sides are equal, is different from the other side, then we have shown that the 3 points are isosceles triangle. So we can now write Hence, the points are vertices of isosceles triangle. And that completes the proof. Let's take another example. So these are the examples, but these examples you are going to solve it yourself. But I will explain. Determine the nature of the following points. Now, if you have 3 points, you should know that they are talking about triangle. You should know that they are talking about triangles. So they want to they want you to show which type of triangle is this, and you now need to know the type of triangle we have and their properties. For instance, we know that right angle by Pythagoras Theorem, let's say this is ABC. We know that AB square will be equal to AC square plus BC square. So if you can show that, but the main thing is that you need to pair them just like the way I did here. When you pair them, if you cannot show that if you square one is equal to addition of the two other sides, the squares, then you have shown that, then you tell us that it is a what? It's a right angle triangle. So I've told you about the vertices of an isosceles triangle. If two of the sides are equal. Another thing is equilateral triangle. If all the sides are equal. If you have found it, if you pair them like that, the way I paired it here, and you find out that all the sides are equal, you should know that it's an equilateral triangle. And if all the sides are not equal, you should know that it's a scaling triangle. So that is only what they want you to do here. Also, for this one, you have to show that these points are vertices of a rectangle. What you need to do here is you pair them as usual. You find AB, you find BC, you find CD. You can see AB, BC, CD, and back to DA. So when you pair them like that, for you to show that points are vertices of a rectangle, you should know the properties of rectangle, which says this. You know properties of a rectangle. If this is A, this is B, this is C, and this is D, we must have that AB must be equal to CD, and then BD must be equal to AC. So if you have paired them like this, you now need to show that two opposite sides are equal. That is, you are going to have 4 pairs. So you only need to show that 2 of those sides are equal to each other. So if you have shown it, it's a rectangle. So another one is a square. When you are given like that, properties of squares, all the sides are equal. Another one is a tetrahedron. So this is shape of tetrahedron. So the vertices, they are also equal. So we only need to pair them, and if they are equal to each other, we have shown that they are vertices of tetrahedron. So let's move to division of line segment. So the division of line segment under the two-dimensional coordinate system also extend to this. It's still the same thing, and the coordinate of midpoint there is still the same thing. So the thing has not changed. So we start from the first one, the coordinate of midpoint. So under the two-dimensional coordinate system, we know that we stop here for the coordinate of midpoint. But now if you are not dealing with coordinate of midpoint of three-dimensional coordinate system, that is point S1 to Z1 and this. So we extend it to this, comma Z1 plus Z2 over 2. For the division of line segment that is joining points A and B in the ratio M, ratio N, we know that this is it. We stop here for two-dimensional coordinate system. So it has been extended there. We have added Z part to it. And finally, for the external division of line segment joining points A and B in the ratio M and N is given as this. So we need to take note of everything. So this is formula of finding division of line segment. This is a point that divides this thing internally in ratio m ratio n, and this one is the coordinate of midpoint of this. So let's take example for this. So we have the question here. Find the coordinate of midpoint. That is the first one. Second one, find the coordinate of points dividing the join of this and this in the ratio 3 ratio 4. So solution, according to our formula, the first one, coordinate of midpoint is this. So we have known our S1 and S2. So this is our S1, this is our S2. So this is minus 3 plus 5 over 2, comma, y1 plus y2, 1 minus 1 over 2, comma, 4 plus 6 over 2. And that will give me 1, 0, 5. So that is the coordinate of midpoint of these 2 points. Now, for the second one, you observe that the question does not specify whether internally or externally. If the question is not specified, then the question is talking about internal division. And the coordinate of internal division is given as this. Now, what is our m? In that question, this our small m is 3 and our n is 4 here. So this is m ratio n. So we cannot be putting everything there, so that we are going to have m 3 times s2. That is 3 times 5. So let's quickly write it out. Our s1, okay, let's put the point here. This is minus 3, 1, 4, and the second one is 5 minus 1, 6. Now, so this is m times s2 plus n, which is 4, times s1 minus 3 over 3 plus 4, m plus n. We do the same thing for y. This is 3 times y2. Our y2 is 1, as you have seen, plus 4 times y1. Our y2, is minus 1, and our y1 is 1 over 3 plus 4, comma, m, which is 3, times z2. Our z2 is this, plus 4, which is n, times z1. Our z1 is 4 over 3 plus 4. So it's now left for us to simplify. So by the time we simplify, we get 3 over 7, 1 over 7, and 34 over 7. So that is that about that. Now let's take another example. Another question, find the ratio in which YZ plane divides the segment joining these points. Now, solution. The first thing is, let the ratio be m ratio n. As usual, if you use the formula, we are going to have this m times s2, that is m s2, that is 3m minus 2n over m plus n, comma, for the y2, we do the same thing for y, my2, that is minus 5m plus ny1 plus 4n over m plus n, comma, and finally 8m plus 7n over m plus n. Let's keep this. Now, the question is, in what ratio in which this YZ plane? So for YZ plane, if they say that YZ plane simply means S is equal to 0. So it's just like under two-dimensional Cartesian coordinate. If you say that y-axis, we mean that is where S is 0. If they say that x-axis, that is point where y is 0. So YZ plane is a point where S is 0. And this is the coordinate This is x coordinate of point that the ratio divides. So this place will be 0. So in that case, we have that s is 0. So we have 3m minus 2n over m plus n is equal to 0. From this case, we have 3m is equal to 2n. So you can do it in two ways. You can say, you equate it together. You can say that m is equal to this one and n is equal to this one. And if you don't want to do it like that, you can do it in another way like this. You can say that m divided by n, so that here m ratio n will just be, m is 2 and n is 3. So that m ratio n will be 2 ratio 3. Or you do it like this. You divide it, m divided by n. This one goes to the other side. We have 2 over 3. But m divided by n simply means m ratio n. 2 divided by 3 simply means 2 ratio 3. So it is 2 ratio 3. 2 ratio 3 is the ratio in which YZ plane divides the segment. If the question changes to SZ plane, you should know that that place is y is equal to 0. We are dealing with this. So that is that about that. Now the next one is we go to centroid of a triangle. So coordinate of centroid of a triangle. Before we talk about what centroid means, we need to first define this median of a triangle. If they say that median of a triangle is a straight line, look at this. Where we have this now. If they say that median, if you draw one line to bisect this into two equal parts, then this one is equal. So this line is called median of a triangle. So we define it as follows. So we say that it's a line or a straight line which is drawn from one vertex of a triangle to bisect the opposite side of the triangle. So this is what we are trying to see. So this line here is the median of the triangle. So that will now lead us to what we call centroid. Centroid of a triangle. If they now say that centroid of a triangle, we define it as follows. This is a point where the medians meet, because for a triangle we have 3 medians. This is another one. This is another one. So where they meet here, this is centroid. So let me redraw it here very well for better understanding. I may not be perfect in my drawing. So let's say that is one median, this is another median, and this is another median here. So we assume that this size and this size are equal. So we assume that those sides are equal. Also, it has been proven that this point, this median, divides this centroid. This place is a centroid. It has been proven that this place divides this line in 2:1. This is 2:1. This is 2:1. So that is, it has been proven that. So this will help us to know the coordinate of centroid of a triangle. Now, let's now find the coordinate of centroid of a triangle. Coordinate of centroid of a triangle. So let's consider this. This is point P here, point Q, and point R. This is the point G that we want to find. And that point G is named as the centroid of the triangle. But we need to first find this N, because by what you have said the other time, that this G divides this PN into 2:1. So let's keep that. The first thing is, what is point N? You observe that point N is the midpoint, because we know that by definition of median is a line that moves from this point P to bisect this QR. So this side and this side are equal. Definitely n is the midpoint. So using the midpoint formula, we know that the midpoint of the two, this is Q and R, will be S2 plus S3 over 2, comma, Y2 plus Y3 over 2, comma, Z2 plus Z3 over 2. So this is the point N. So this is our point N. Now, we now know that G, but, let me write it like this, but G divides Pn in the ratio 2:1, as we have done. It divides this in ratio 2:1. So from this place now, what we do is we use the formula for division of line segment in this. So this place is our M, this is our N. So our G will now be equal to M, you know it is MS2. So this is our S2 here, this is our S1, the whole of this is our S2. So it is MS2. Our M is 2. MS2, that is 2 times S2 plus S3 over 2. That is MS2 plus NS1. Our S1 is S1. It's just S1 over M plus N, 2 plus 1, comma. So we do the same thing for y-axis. For y-axis 2, it is my2. So this is representing our y2, the whole of that. That is y2 plus y3 over 2 plus n. Our n is 1. This is our m, this is our n. Plus n y1. Our y1 is still our y1. That is 1 times y1 divided by m plus n. 2 plus 1. Let me put the third one here because of space. The same thing is applicable to that, to the z part. That is z2 plus z3 over 2 plus 1 into z1 over 2 plus 1. So this will just give me, if you look at, you see that this cancels this. What we have left is s1 plus s2 plus s3 over 2 plus 1 is 3, comma, y1 plus y2 plus y3 over 3, comma, z1. If you look at this one too, z1 plus z2 plus z3 over 3. So that is the proof of coordinate of centroid of a triangle. So it's giving us s1 plus s2 over 3. This is coordinate of centroid of a triangle. We can prove it in another dimension too. So let's take example on this. So find the coordinate of centroid of a triangle having vertices this. Now it's very easy with what we have said. So the centroid will be the point G. So this is, we know that this is a formula. And you have known your S1. This is S1. Sorry, this is S1, S2, S3. So that is 2 plus 3 plus 4 over 3, comma, Y1. 3 plus 1 minus 8 over 3, comma, minus 4 plus 7 plus 2 over 3. Now, we now need to finalize it. So, easy simplification we give 3, comma, minus 4 over 3, comma, 5 over 3. So that will be the coordinate of centroid of the triangle.